Hello everyone, I'm Adam. In this problem, we're going to be taking for our given vector v with components 3 and 12, we're going to be finding the unit vector in the same direction of v, and then we're going to be verifying that that unit vector indeed has length 1. So let's start with how we find a unit vector in the same direction as a vector v. Well, what we know to find a unit vector, which we'll call u, that can be found by taking the vector v and dividing by the length or magnitude of v. Or another way of writing that is to multiply by 1 over the length or magnitude of v times v, where, of course, v is a non-zero vector. Hey, now I prefer this form because that kind of reiterates the fact of what we're doing. We're taking a scalar, the length, 1 over that length, and multiplying it times the vector v to get the unit vector u. And of course we call it a unit vector because its length is 1. So pictorially we can kind of get an idea about that. Of course, memorizing formulas is all good and well, but it's good to understand them. If we take, say, our vector v, we'll just take it somewhere in space. Okay? And this, of course, has length with whatever we're calling this magnitude of v. If we multiply by 1 over that magnitude times the vector v, think of something having length 5, and you multiply it by 1/5. How long is it now? Well, 1/5 times 5 gives you 1. So the unit vector in the same direction of v is actually a vector in the same direction, but actually falling kind of in line with v, where now the length has been scaled back, which is why we call it a scalar, to be equal to 1. Or it could be likely scaled up if v is shorter than 1, but this will suffice. Okay, so what we need to do, looking at our formula, is we're going to find the magnitude of v and multiply it with the vector v. So that's where we'll get started. So starting by finding the magnitude of v, so the magnitude or length of a vector is equal to the square root of the sum of squares of its components, so the square root of, say, v1 squared plus v2 squared, where in our given vector v, our v1 is 3 and our v2 is 12. So this is going to be equal to, say, the square root of 3 squared plus 12 squared. So 3 squared is 9 plus 12 squared is 144. So that gives us the square root of, say, 153. Now we can leave it like that, but to save ourselves a little bit of time in the future work that we're going to do, we'll simplify this square root by bringing out any squares that we can, as we've done in algebra. So 153, if we look, is or can be written as, say, 9 times 17. So square root of 9, bringing that out, is 3. So the square root of 153 can be written as 3 times the square root of, say, 17. Okay, so there's our length, or our magnitude. Get back to our formula, our unit vector, u, right, which is taking 1 over the magnitude of v times the vector v, which is 1 over the magnitude, which we have as 3 root 17, times the vector v, which is components 3 and 12. Okay, now we have the scalar multiplied by a vector. And remember, when multiplying a vector by a scalar, we just multiply each component by that scalar. So this is going to be equal to the vector 3 times 1 over 3 root 17, or 3 divided by 3 times the root 17, and 12 times 1 over 3 root 17, or 12 divided by 3 root 17. Okay, and we can just clean this up a little bit. So we see here our 3's are going to cancel, giving us just 1 over square root of 17. And our 3 will divide into 12, giving us 4 over the square root of 17. And we can leave it like that, but we'll clean it up just one more step by rationalizing our denominator, and we do that by multiplying top and bottom of each component by the square root of 17 over the square root of 17. So this 1 over square root of 17 will be, say, the square root of 17 over 17, and 4 over the square root of 17 will be 4 times the square root of 17 over 17. So that gives us our unit vector, u, that has length 1, which is what we're going to show in a moment, that's in the same direction as v. So let's go ahead and show the last part. So we want to show that the length of u, or simply the magnitude of u, is equal to 1. Well, how do we do that? Same thing that we did with v over here. We have the magnitude of u is equal to the square root of the sums of squares of its components. And so its first component is the square root of 17 over 17, and we square that, and we add that with its second component squared, 4 times the square root of 17 over 17, and we square that. So from here, we could just plug everything into a calculator and see that it comes out to be 1, but we'll simplify things by hand here. So this gives us the square root, squaring square root of 17 over 17, we get 17 over 17 squared, which is 289, plus squaring this term 4 times the square root of 17 gives us 16 times 17 over 17 squared, which again is 289. So a couple different ways to do it. If we just notice that 16 times 17 plus 17 gives us 17 squared, which is the common denominator, 289. So this can be simplified to the square root of 289 divided by 289, which of course is the square root of 1, which is 1. And so we verified that our unit vector has length 1. Thank you very much.